let's see the exercise on sketching the following piecewise defined function. And after that, you're asked to state its domain and also the range. So let's see this piecewise defined function here. You can see obviously you have two separate equations. Okay, so let's name it as equation 1 and also equation 2. Okay, why does the equation being separated? Because it is according to its domain. Okay, so this is a domain for the first equation, x less than or equal to 1. Another one, x is more than 1. So you can see that the number 1 here, we call it the endpoint. Now let me show you how do we graph this equation. So let's take the first equation, which is for x less or equal to 1. Therefore, your function will be fx equal to x squared. Okay, so you know that this is a smiley graph, so let's graph it. Make sure when you want to draw a graph, you must write first the x-axis, the y-axis, and origin. So now this is a square graph. Then let us draw a smiley graph here. You know that for a smiley graph, we need to give a few points. For example, 0, 0, and then this is 1, 1, this is minus 1, 1. Okay, so that is the basic coordinate that you need to give for a square graph. So now, let's look back to our endpoint here. Okay, let me write here your endpoint. Okay, so your endpoint is the point of 1. So you have already the coordinate of 1. When x is 1, your y is also equal to 1. So this is the point, 1, 1. So what we want to take from this graph here is just from 1 and then less than equal to 1. So from this graph, we only want to take x less or equal to 1. So let me highlight for you. We just want this graph here. And at the end point, it can be included. Okay. Therefore, at the answer of piecewise defined function, you can now transfer this point and transfer this graph here. So let me do it. Let me show you. We want to transfer this graph here. Okay, this one goes to infinity. So we want to transfer this point here, 1, 1, and then this is 0, 0, and then we have here minus 1, 1. So we're finished with graph number 1. Let us go now to graph number 2. For graph number 2, the domain is just x more than 1. And then the function involved is fx equal to x plus 1 here. So you can see that this is a straight line function because x here is power of 1, a linear function. So let me show you what's the easiest way to graph a straight line. So for a straight line, you just need 2 coordinate and then just connect the 2 coordinates, therefore you'll find a straight line. So let's write the easiest coordinate is 0, so when x is equal to 0, your y is equal to 1. And for another one, let's just use our endpoint here. Okay, so when x is equal to 1, your y now is equal to 1 plus 1, it is equal to 2. So now we have 2 coordinates. Let's graph the 2 coordinates. Let's graph 0, 1. So 0, 1 is somewhere here. Now let's graph this endpoint here, 1, 2. Okay. So 1, 2 should be somewhere here, 1, 2. And I can write here 1, 2. Now in order to draw a straight line, just connect these 2 dots here. So let me show you. Connect this 2 dots, therefore this is your straight line. So let's see where is the graph that we want to take. We want to take x more than 1. So we already have the coordinate 1, 2. However, you can see that the point 1 here is not included. So let me draw a hole here at 1, 2. And then we just want to take 1, 2 more than it. Alright, so this is the graph that we want. Let me highlight it. So we want this endpoint not included, and we want this shape of graph. So now let's transfer the point and transfer the line here. Okay, let's start with transferring the point. We have 1, 2. So we already have 1, 1. So 1, 2 is somewhere up here. Okay, this is not included. So after you transfer the point, endpoint here, let us transfer the line. So this is just a straight line going upward. Since this is the final graph, you can write the last one as arrow here. Therefore, this is your final graph of piecewise defined function. Now, let's see. The question wants us to state the domain and range. So let's start to finding the domain. So the way to write your domain is D, your domain, x equal to, so let's find where does the graph of x exist. So this one is going to negative infinity, so this is all included. Okay, up to this point here at x equal to 1, this is not included, but this is included, so you can still go on. Okay, at this point here, the point still exists, so you can go up until infinity. So it is all real number, or in interval form, you can write from minus infinity until infinity. You can see this also from the function. Okay, so from the piecewise defined function, we have covered x is less or equal to 1, and then you continue 1 until infinity. Now, let's see for range, okay? So for range, you are looking at the y-axis. Where does it exist? So now let's start with negative y-axis. So you don't have any graph down here. The only graph that you're starting to have is here at y equal to 0. And this is included. So let's go up here. This is all included. You still have graph up until y equal to 1. But you can still go on because this graph is going forever. So this is also included. So at this point, we have found another crisis because here 1, 2 is not included. However, you still have a graph over here to cover it. Okay, so you can still go on, and then it goes up until infinity. So now let's conclude our range. It is y starting from 0 included until infinity.